Dear students, we'll see embedded system design process today. This is a very important topic of the first unit. The embedded system design process aimed two objectives. One is it gives introduction to the various steps involved in the embedded system design, and it allows the user to consider the design methodology. When we talk about the design methodology, it ensures that performance of the system, and also it will provide clear steps of specification, architecture, and also the very important one is it is easy to communicate to the team members. The team members can more easily understand what they are supposed to do, what they should receive from other team members at the certain times, and what they are hand off when they complete their assigned steps. So because most embedded systems are designed by teams, coordination, and perhaps the most important role of well-defined design methodology. Next, we will see what are the major steps in the embedded system design process, or we can call it as what are the abstraction levels are in the embedded system design process. Here, the abstractions start with requirements, specification, architecture, components, system integration. Here, the system design process have two different design process. One is a top-down design process and a bottom-up design process. So what do you mean by top-down design? The top-down design means, suppose you are designing a new product that is not available in the market. Okay, so then what you will do? So if you have to collect the requirements. Well, let us consider one. You want to produce one product. You want to design one product. Then you have to collect the requirement of the product, and then you have to move on to the specification of the requirements, and you have to develop an architecture for your requirements. Then the components. Then it may be the hardware part or software part. You have to integrate software part and hardware part in the system integration. Finally, you will get the product. So if you follow this, then we can call it as top-down design process. That is starting with a requirement and specification. What are the specifications required for your product, and what are the architecture required for your product, and you will collect the components, and you will integrate the software part, hardware part. That is called the system integration. Then this process is called top-down design process. Okay. Now, something you are missed in your product is developed now. Now there is something missed. So you may have a particular function may not be run, or memory will how much memory you need, or is it will run in a particular time. The task is completed within the time. So there is some bugs in that product. Then you have to move from the system integration. From the system where the debugs in the system integration. Then if you add the which components will complete your task, or whether we have to change the architecture, or which specification required for our product. Then whether the product is meet out our requirements. If you go like this, then we can call it as bottom-up design process. So there are two different design of the embedded systems are top-down design, another one is bottom-up design. The top-down design begins with the abstract, most description of the system and conclude with the concrete detail. But the bottom view is start with the component to build a system. Okay, so this is called embedded system design process. But the steps in the design process are only on one axis, along with we can view embedded system design. We also need to consider the major goal of the designs. What are the major goals of the design, embedded system design? The major goals are manufacturing cost, performance, and power consumption. These are the very important major goals. So manufacturing cost. So while designing this, that is very important, manufacturing cost, right? And suppose if you want to buy a mobile, what you will think about first? You will consider the cost. whether the mobile cost is it is up to your level. Okay, so the manufacturing cost is very, very important. So the customer will have to, they will see the performance also. So let us consider the specification of this Apple phone and Samsung phone may be good, but the cost wise, when you talk about the cost, the Apple cost is much higher than the Samsung. But when you talk about the performance, the mobile, the Apple is better than the Samsung. So here it will, the major goal is manufacturing cost or performance. So another important goal is power consumption. You may think some of the customers need, they will consider the cost. Some of the customer will think about the performance, but some of the customer will think about the power consumption. The power consumptions, so some your designs may be in a stationary or it may be movable. So depends upon that, you have to consider the power. So these are all very, very important major goals. Okay. So the another one is, we also consider tasks we need to perform every steps in the design process. We have to consider when every steps, this is not only finally you have to consider in every each and step, whether it's a requirement, you have to consider cost and the performance and consumption, power consumption. If it is a specification, then you have to consider the, there also the cost is very important, performance is very important, power consumption is very important. So each and every step you have to analyze the design at each step to determine how we can meet the specification and how we must then refine the design to add a detail, and we must verify the design to ensure that it still meet all our system goal, whether it is a cost such as cost, speed and size, everything. These are the very, very important. So top-down design start from the most abstract description and work to most in a detailed way. In a bottom design, we work from small component to big system. Okay, so the real-time designs are used both techniques. It is very, very important. We need both the techniques. So if we want the from scratch, you have to start. You have to use the top-down design process. For if any minor changes, you have to go from the bottom-up designs. When we design a process or a system, we must know what we are designing. So initially, we have to gather the informal description from the customers known as the requirement. The requirement means the informal description from the customer is known as a requirement. And we have refined the requirement into the specification that contain enough information to begin designing the system architectures. So here the customers maybe they give the unrealistic expectation as to what can do done within their budget, and they may also express their desire in a language very different from the system architecture. So you ought to consider, you ought to get the complete detail from the customer through the language description of what the user wants and expected to get, and maybe we can develop this, get the detail in a several way through talking directly to the customer and talking to the marketing representatives, and we can provide the prototypes that this is the way you will get this, whether we can include some requirements or are you satisfied with this. All these comments you have to get from the customers. The requirements may be either functional or non-functional. So we must capture the basic function of the embedded system is called the functional. What is the input and what is the output? But the functional description may not be sufficient. So we require the non-functional requirement also. What is this non-functional requirement? Here the first one is the performance. But the performance means speed of the design. Okay, speed of the product. Okay, that is the major consideration of both the usability as well as the cost. If you go for high performance, then your cost may be increased. If you go for low, then cost may be reduced. So these are the important non-functional requirements. The customer may not know about all these things. You have to get the details, whether they need a speed or less speed with the power consumption. All these things you want to collect from the customers. The second one is the cost. Here the cost means the total cost of manufacturing cost and non-recurring engineering cost. What is manufacturing cost? The manufacturing cost consists of the component cost, assembling cost. All this comes under the manufacturing cost. But non-recurring engineering cost means it completely includes the personal cost. What do you mean by personal cost? If you are traveling for getting some information from somewhere else, on the collecting the data, and you are advertising something. So these are all comes under the non-recurring engineering costs. So total cost consists manufacturing cost and non-engineering cost. And the next one is physical size and weight. Here the physical size is another important, that you have to get a complete detail from the customer with the what is the size of the components, where they are going to fix, what about the weight. All these things you have to get the detail from the customers. That is very, very important. So the next one is the power consumption. Power, of course, it is very, very important. It's a battery powered system and it is often important in other application as well. The power can be specified in the requirement stage. In terms of the requirement stage itself, you have to get the details from the customers in terms of how much battery life they require. The customer is unlikely to be able to describe the allowable wattages. So these are all very important. The utmost requirement is validating. Validating requirement is another very important one. Is validating the set of requirement is ultimately the psychological task, because it requires the understanding both what people want and how they communicated those needs. So validating is very, very important. Requirements analysis for the big system can be a complex one,